welcome to Unapologetically Technical. My name is Jesse Anderson. This is the show that's different. We go very technically deep. We go all the way down, and we're unapologetically about it. With me today is Matteo Merli. He is the CTO of StreamNative. He's also the PMC chair and co-creator of Apache Pulsar. So we're going to get deep into Pulsar, a lot of things. Welcome, Matteo. Would you mind telling us a little bit more about yourself?
I just say thank you for having me here. Yes, I can give you a very brief history. I I'm working in Streamnative right now, and before that, I go back a bit. I've been working in Yahoo for several years, and I was part of the distributed databases team and messaging. And we started. I work on different messaging technologies around there, and the part of that work was creating a new generation messaging system, and with that with Pulsar through different iterations there, and then it was brought to production and open source at the end of 2016. And after that, we started the first company around commercialization of Pulsar and other technologies. And that was acquired by Splunk in 2019. And after that, after a couple of years, I went back into the startup world with CG and working on StreamNative and Pulsar again on the from a from a startup vendor point of view.
Yeah, we'll get deeper into each one of those companies and things that you've
Yeah.
done along the way. So, you throughout your career, I noticed this common thread of communication and protocols. Why are you so interested in these two things?
Oh, very good question there. So actually, my first interest was around. I always been like fascinated by databases and the way you could store data since I was in college, and so I would try to understand more and more like how. I mean, you have this very abstract concept like SQL and like all these very high level concepts, and then okay, but how this is physically stored on disk, right? Because at the end of the day, you, you have files, you have disk setters, and how the how different systems use that in efficient ways and so on, and how indices work. And like all what's kind of like internal database stuff that was always fascinating to me. And um, so, and after a while, I also got interested a lot in distributed systems, and I mean, it was like the late 2000s, so that Hadoop was all the rage, and all these new like HBase and new technologies were coming up. So when I got the opportunity to go to Yahoo and work on this database, that was okay. I mean, I don't need to know anything else. That was the space I wanted to be in, the basic distributed systems, and and I think I got there casually, so that basically I got assigned to work on the replication bus for this database in Yahoo, and that's where I started working on messaging. And one interesting part was that so Yahoo they basically had this massive database, which was one of the first NoSQL database in production anywhere, and they also wrote a very nice paper that was called Peanuts back in the I think it was 2008 or nine. The original paper went out, and they have this beautiful architecture that was based on having a reliable messaging bus for the database. So basically, like every write on the database gets written into the write ahead log, which is a distributed messaging system, and that is used for both durability and of your write, as well as for replication. And replication to a different storage node within the same region, but also replication to a different region altogether. Right? So that's what like a very powerful architecture there, and they describe everything around the database. But in the end, the part of the messaging bus was kind of like left as a black box. Yes, we have this reliable messaging bus that will have all these properties, but we are not telling you how does that look like or how it's going to be implemented in practice. And so what happened there was few attempts to build that kind of like a messaging bus using like a distributed approach, and they failed for like many different reasons. They were too expensive to build, or like they were not as performant as it could be, and so on. So in the end, the thing that succeeded was to use the old approach. So Yahoo had technologies dating back from the 90s to do like communication across nodes. So essentially, they kind of reuse that and in conjunction with kind of like using things like NetApp filers, right, and NFS mounted storage, and kind of build that messaging infrastructure for that problem. And that was kind of like, I think it was also a reminder that sometimes like you have fancy architecture, fancy ideas, but it's very hard to get them to operationalize something and make sure that works at scale with all the unknowns and all the problems that can end up. And sometimes like the low technology solution can be the best one in the short term. I'm not trying to. I'm trying to not generalize here, but it was really a lesson that essentially they couldn't bring those new architectures in production but the old school one kind of worked for several years, right? And of course, I mean the limitation were known. You cannot like increase capacity just by adding filers, because yeah, it's a very operationally involved operation process there, right? And there are all sorts of limitations, but at the same time, like it is much easier to bring something of good reliability out instead of like trying to kind of like have an overarching new approach and so on. So yeah, that was my first exposure to messaging and all the problems there. And with that, we learned a lot of lessons on what to do and what not to do on operating at large scale. So it was system deployed on thousands of nodes, and it really like I mean to me it was really eye-opening. I can thinking as have a system kind of like approach to the problems, right? Like if you think that none of these nodes run in isolation, right? You cannot think of a problem that is limited to one single machine. This is like overall system, and whenever there is something that affects one node, it will very, very quickly propagate to other nodes or to other regions. Like we had multiple instances where you have an outage in one the data center, and because the other data center they have now to accumulate more data, and you're putting a lot of stress on those data centers. So now, when you are like trying to react and say, what can I do here to make sure that I don't lose data, I don't have these outages to spread across the different centers, there's a lot of very decisions that are kind of like very difficult to make and require really understanding how the system works under stress and how the stress in one component affect other components. And that's very hard in general, but I think it's also one of the most interesting parts of this job, right? To design systems that can be more and more reliable, that can be more and more scalable, and that can be more easy to operate. Trying to kind of like apply all the learned lessons from the past.
Yeah, there's as I think, as you rightly point out, at the base of virtually all of what we do in computing is some sort of communication. It's when we're a database, when we're using Kubernetes, it's one machine talking to another. Nothing is in its own isolated, as you mentioned. So you personally are from northern Italy, and it's something I've also seen in the rest of Europe that Europe is a pretty conservative adopter of technology. Why do you think this is?
Uh, I I think there are several, there are not one single reason, and there are many reasons, yeah, I try to be not generalize too much, but I believe that you you can think of it as the in general, people are much more risk averse in Europe. I think that's Europe in general, right? Not just like technology averse. Is the tolerance for risk is much lower compared to US culture, and I believe that there are multiple reasons for that as well. The one part for technology startups and the environment, I think, has been historically like the ease of access to capital. I think that has played a big influence in there. But of course, I mean, it's not. There are also other reasons for that lack of easy access to capital. In the end, I do believe that has changed a lot since I left Europe in the past 13 years. I've seen like each time I come back, I see that there are more and more startups, more and more companies building like hard technology and doing really interesting stuff throughout in Europe. Uh, I do I do see though that there are only few pockets of these tech hub. I mean, you can see in London, you can see in Berlin, to some extent Paris. Out of that is not very it's not very active the community, but definitely I can see that it is much more active right now. So I also spent 3 years in Paris before coming to US, and honestly, when I was there, it was like 2007, 2010. The only big startup story, successful startup story in Paris was Dailymotion, which was like I mean, it was competing with YouTube at the time, right? And but at the end, like if you look at Dailymotion, essentially was financed by the French government. So it's kind of like it's a very different startup environment where it, like, basically it is fueled by government investment rather than private investors. But after that, I think right now the scene is very different there in Paris, but especially London and Berlin. Um, but one thing that I noticed, I mean, from an engineering perspective, is that there's a lot of talent in Europe, in Europe, and I think that a lot of very good schools. The the cultural difference, though, that I've seen, I mean, as a European in the US, is that when you come to US, there's a lot more optimism in founders, engineers, and they kind of like open up for like bigger ambitions. That I don't want to just build something that. So I want to solve all these other problems. I want to have a much bigger impact, much bigger scope. And my conclusion, again, I can be terribly wrong here, but it's kind of like comes from also from the education system, education culture, as a thing that back in Europe, back in the, and I've seen this not just in Italy but elsewhere in Europe. Like you're in school, you're kind of like they will put in your mind the idea that you're uh, you're learning old stuff, but you're how can I put it, that like that you know nothing, right? So that's the idea. So it doesn't instill that level of confidence when you get out of school. Essentially, you're not thinking that, oh, I know a whole stuff, I can do whatever I want. Is more that, oh, yes, you have you have gone through this course of study, but you know nothing, right? And now you have to start and build your own career, but I think that the level of self-confidence that students come out of school from elementary and to college, I think that's valid throughout the course of study. In US, it is very different, and that I'm seeing this with my daughter here in California, that they kind of like have that self-confidence that me and everyone else was not instilled in the education system. I think so. I think that it plays a lot of role because if you think you know nothing, then how can you like convince yourself that I can solve all these hard problems? I can go and compete with other companies and build a company or like work on hard stuff. So my impression that plays a big role there culturally.
Well, the other day, somebody told me that if you have a company that fails in Italy, that you can't found another company. And I think that goes to that other part of the
Yes,
conservatism of if I fail at
yes,
this, there's not another go. You just that's it. You're done. And it just kind of
yes,
crazy to me that you would be have to be that conservative.
sure. And for most companies in Italy, like if you want to build a company, basically you have one option to raise money, which is to go to a bank, and and the and the bank is not like when you go to an investor here, and it basically we ask, okay, what is your collateral? Do you have a house, or do you know someone? It's not really based on the merit of your idea, which these banks are completely unequipped for evaluating the merit of. It will be basically okay. Uh, how can you guarantee to give me my money back? That's the only thing there. So it is very very hard to you know, ecosystem building up. Um, but one thing that I think that in the last few years though, I'm seeing more and more um, companies that are more willing to hire engineers in Europe. And I think that in the midterm it should change a lot, because now once you start having like pockets of people with a very deep experience in many areas, I think that should uh, uh, help a lot in building more local ecosystem in those areas.
Yeah, and I agree with you. There's some pretty top-notch engineers here in Europe. They don't get as much, I guess, cred or street cred as in the US, but there's some really top-notch people here. So companies that are watching this, there are people out there. So let's kind of rewind earlier in your career. And so you specialized in the communication and protocols, and it sounds like that would be a recommendation. So would you, how early do you think people should start looking at how to move up in their career? Because I noticed you rose pretty quickly.
I My suggestion would be to find something that is some there are many areas in tech and software that are they have a lot of hard problems to solve that have been worked on for many years, but they're very active areas of development. I would say my suggestion would be to find one that is interesting for a person and build that experience on that and focus on that area, but something that you like on, because otherwise, yeah, is is it's not useful to just okay, I want to do this because everyone is doing it. That's not okay, a good reason, I guess. Um, but like it the I think that in most cases it takes a bit on to really learn and uh, how a certain area of software industry works. Like if you specialize in databases, if you specialize in database systems and messaging systems. So these are all very complex technologies, and it takes a while to master. And it's not something that you can master everything at the same time. So focus on one particular upset and try to go as deep as possible. And I think that it's always useful, and the same lesson that you learn when going deep in one technology, you can also apply them in a different technology, in a different area. So I don't think that going deep goes against going more broad in general. But if you only go at the broad to begin with, and you just learn like the a shallow part on each different areas, but you're missing a lot of the understanding on how things work underneath, and how to learn how to understand the system. If you only see the surface of many of them.
So, what your biggest jump in your career, it sounds like, was moving to Yahoo. So, at that time, you were in Paris and then you moved to Sunnyvale. So, how was that transition for a European coming into Sunnyvale, other than the bread not being as good?
That was one thing. The other one was, I mean, you get to a completely different country, and you have to learn lots of different things. First of all, like, yeah, there's no people in the street in Sunnyvale. That's and when you move country, you should do more research on where you want to live. That I think was one of the lessons. So I spent the first year in Sunnyvale, and then my wife and I, okay, let's go to the city. So we moved up to San Francisco, and then after kids, we moved down to the peninsula again. But I think that's a very hard to know upfront where do you want to live there. I think I was pleasantly surprised that it was easy to integrate in the work environment. That's, to me, like the best part of like working here in the US, California, is that it's like nobody asks where do you come from, or even where do you study, or how was your English accent, and or your English grammar compliance. That's really something that people don't care. So if you can show that you can bring value, and by writing code, by fixing stuff, fixing systems, and so on, I think that's everyone will welcome you. So it's a very different, again, scenario from where you get in Europe. Like in Paris, if you don't speak perfect French, it's very hard to integrate well in the local scene. Also, like if you have not studied in local university, you're kind of like a very unknown quantity for companies there. Again, I think this is changing, slowly changed, but it was very, very well present when I was there. So it is much harder. You have to fight much harder to kind of like demonstrate what you can bring on the table. And so as well in Europe, right? But here, yeah, nobody care about my accent. Nobody care about my very broken English, and that makes many things much easier. So that on that front. But yeah, I mean, changing continent, changing country is always a stressful moment for everyone. But I think it was professionally was very good decision. Try to be able to get this kind of type of experience. I think that was something that I couldn't have got that 13 years ago in Europe. And I mean, I was always like jealous of like seeing like interns coming to Yahoo or companies like like you have these opportunities to work on like very cool technologies right out of college, and seeing that okay, the opportunity we got in Italy or Europe in college was nowhere near that in terms of like internship or like out of college opportunities. So I'm really was really grateful to have that at least after a few years of experience to be able to have that kind of opportunity.
You point out something that I guess I haven't really thought of because those of you who are watching, when you see a resume in Europe, they'll have a language section. And in the language section, it will say, is it A2? Is it B1? Is whatever it is. Because although let's say you're in Germany, you'll have, this is how well I speak German. This is how well I speak English. This is how well all the way down the line. And each one of those forms up of whether they're going to hire you because if the company only speaks German, if the company only speaks English, or what have you. So it's pretty rare in the U.S. for there to be for somebody to either put the languages they speak or the level of fluency that they have of those languages. So yeah, that is a pretty interesting part to it.
Yeah, but even in UK, I think that it's like if you don't speak perfect English, it is much harder to be taken seriously. Right? Same with French in France, but in I think that it is much more lenient here in America. The fact that yes, you may be making mistakes in the language, but I mean, I'm not a PR person. I'm not a marketing person. I'm an engineer. As long as that does not impede like uh, uh, communication with other engineers, that's not a blocker, right? That's not a problem. Um, but it is a big problem in other countries.
It is. So talking more about that Yahoo transition, you were working on cloud messaging. You kind of introduced some of the concepts around it. When you were interviewing them, what made you so interested about it and said, "I will move across the world to start working on that project"?
Uh, I again, my main motivation was to work on this with the system. So uh, when I got wind that I got the opportunity to work on this massive database, that was okay. Where do I sign? Uh, and I think it was a too good opportunity to work on the database in distributed systems. I think that was the the only thing that I needed to sign.
Okay. And so now you kind of referred to it. You said there was this messaging system, but the messaging system was kind of an aside in the paper. It wasn't really talked about. So let's talk about you deciding to create Pulsar and why what motivated you to do that.
Yes. So when I got there, as I mentioned, so we had this like old school system that was uh, put together to make this database work, and we quickly saw that okay, this is working, but we're gonna hit some of the limitations are gonna bite us in the near future. So, and we had already like a lot of lesson learned in production from incidents and kind of like understanding a bit more on the challenges of running this kind of like a messaging system at scale, especially like when things go a bit out of their normal operating range, and how can you recover and so on. Taking all these lessons, and I think that there was a push in the company to kind of like rethink a bit more on the messaging infrastructure one more time. I would say that was not the first attempt, and at the same time there was also an attempt to kind of like unify all these different messaging services that were running and that each product team were running. So you had uh, like hundreds of different product teams in Yahoo building things from mail, from finance, and tons of other products, and they in many cases they were using some kind of a messaging broker, and most of the time that would have been either something like ActiveMQ or TIBCO or RabbitMQ, and Kafka was almost even not even there yet, but it was not a good fit anyway. But essentially, one of the problems was that, okay, on one side we have this huge platform system like these databases that we don't have a good way to support yet. On the other side, we do have these product teams that are built that are like running each of them a small cluster of these messaging brokers, and they have a lot of issues around like it is easy to spin up a new cluster with the ActiveMQ and so on, but when things break in production, these teams that they don't have the expertise to run efficiently ActiveMQ, they don't have the expertise to fix it and or to improve the operational aspect. And therefore, we're trying to come up with a way to unify all of this and offer that as a service. The first approach that was that the Yahoo architecture group was deciding was to have a JMS service, as in that, okay, everyone is using ActiveMQ with JMS, let's build JMS service.
So just to be clear, so in case people don't know what JMS, what is that?
So JMS is a Java messaging
service.
It's a Java messaging
Yeah.
service.
Yeah, Java messaging service. It was an early Java pub sub.
Yes, so it was the pub sub API that was built by Sun Microsystems in the 98, 97, 98. And I mean, had few minor changes after that. And it was the standard. I mean, it has been the standard for many years in the Java world for what pub sub interface is. And then each vendor, they had their own implementation of that API. So you have ActiveMQ, you have TIBCO, you have IBM, and every one of these vendors, they have basically JMS providers. So the idea, okay, let's make a new JMS provider that works with our system and that can run as a service. On paper, that sounds good, right? But I think there were two flaws there. First of all, was that people are not using JMS because they like JMS. They use JMS because it was the only option out there, and that's a big distinction, I believe. Second is that JMS was created in the 90s, and the environment was very different, right? So JMS API was created in an environment where you had one server, where you do planned maintenance on that server, and that server doesn't get restarted otherwise, right? So many concepts in the API are done through thinking about that kind of model, where you have this big server, and that's it. So
I'd also point out that it was also really thought of as being a point-to-point sort of thing. It was one server talking to one client usually.
Yeah, and so if you try to cram that and basically to hide that through a cloud service where you have multiple instances, multiple brokers, and where we're doing things like rolling restarts and so on, that kind of like put a strain on the API itself. And one of the particular problems we had was that we were doing an upgrade, and what was happening is that our user with JMS API were not catching some exception in some corner case of the API, and because of that, they were like left without reconnecting. And there were like so many different ways that you have to catch exception and then recreate all the objects in the API. And it was so terribly difficult that every time we had new users onboarding, they would always have the same issues. And it was like very frustrating for them and for us, right? So it's kind of like showing the limitation of that. You cannot just like stretch the useful life of an API fast. So starting point, yes, there were many good concepts in JMS, but you cannot just take that and make it work in a completely different environment where we have servers coming up and servers going down and be very dynamic about it. So in the past, though, so in that process, though, basically the system we had built was based on ActiveMQ, and we had basically plugged in a server discovery in ActiveMQ that was going to work with multiple servers, and also we had basically plugged in durable replicated storage based on Apache Bookkeeper. That was guaranteeing that when you publish message on these surveys, it was replicated n times. And finally, we also had built geo-replication on top of that. That was one very strong requirement from Yahoo, that we had many products that were based out of multiple data centers. So with that inside, we say GMS is paying. ActiveMQ is not going to help us build a more scalable system. Bookkeeper has been working very well though for us, so that was a good choice there. So essentially, we thought, okay, let's try to rethink and have a version 2 of the system where we can get away from GMS. That's not helpful to 2021, and get rid of ActiveMQ. The process of selling this and implementing this was we cannot just say that we want to we start from scratch. Instead, we kind of went down the road of saying that we're going to do this in an evolutionary way, like adding a different protocols on the broker and then eventually deprecating the old one. So, but in the essence, it was basically carving out everything that the ActiveMQ was doing and defining a new protocol and making sure that we could scale in terms of connections, in terms of producer consumers, in all these different dimensions that we cared about. So we basically kind of like restarted from scratch from within the same code base, essentially, which was an additional difficulty, but it was necessary to not say that we were wrong on most of the stuff. We want to restart from scratch with a lot of risk. Instead of say we want to make sure that we can correct the current flows and have this versionized as quickly as possible.
And so a lot of companies will start out on something like this of let's roll our own, let's do something like this. What do you think went well in terms of convincing your management to say this is the right path?
I think that in like always, you have to prove yourself on some initial kind of use cases, and for us, it was critical to be two use cases were really critical to prove the value of the technology. The first was that the first use case that we onboarded with the new system was the ad system for Yahoo. There was at the time there was basically a major rehauling of all the ad exchange in Yahoo, and like ad systems are very critical to revenue. So they had a very tight deadline, and they say, okay, we don't want to even think about infrastructure. You guys handle it, but make sure that this thing never goes down. And so they didn't have the time to invest in figuring out the solution by themselves, either by looking at other technologies or building something. They have a very burning need to go to production in a few months time frame, and we were almost there. So we said, yes, we can take care of it, and so on. And I remember we had so many meetings in which they were trying to emphasize each time that every minute that the system goes down, it costs n millions of money to the company. So please don't make it go down. Please don't make it lose data. Please don't make it the latency go up, because it's going to be a massive problem. So that was a very high profile system, and we were able to successfully support them. So that was one of the first win that kind of like showed up the value of the technology to the rest of the company, right? And second one was migrating the whole distributed database, sharper database from the old systems to this Pulsar. And again, that was a huge migration that took a year, but eventually it was the thing that was, that was most. So everyone understood that it was a massive undertaking to do this migration and do it live, essentially. So you could read and write that database. There was no interruption there, and we kind of like switch gradually, like table by table to the Pulsar backend. So proving these two kind of like different dimensions of the system was critical to kind of gain that support. After that, it was much easier to convince any of the teams in Yahoo, because they can see the system is available. I don't need to even think about it. I can just request permission for capacity and go in production in a couple of minutes, versus I have to roll out my own infrastructure for messaging. So that kind of model was very successful there, because they don't have to think about operation at that point.
So in between Yahoo and Streamlio, or I should say after Yahoo, you went to Streamlio, and you founded that with a person who's been on this show, Karthik Ramasamy, as well as some other people. Could you tell us about that decision to join a startup?
Yes. So the conversation we had with Karthik, CJ, and others there were around, let's build a comprehensive data platform, right, for streaming, and the idea, which is I think is very valid and very important, is that you need kind of like three components there. You have the complete platform, and so you need messaging for getting data in and out, and routing, and all sorts of stuff. And you need storage to have a very good handling of data, both new and old, and also you need compute. So if you can unify all these components, like storing data efficiently, having very good integrations and ingestions, and very good semantic there, and having very good compute capabilities, that could make a really good story for a streaming platform. Now, so in our case, basically for Streamlio, the idea was we have Apache Pulsar, we have Bookkeeper, we and Karthik and the rest of the team have been working with Heron, Twitter Heron, in Twitter, and let's integrate those and use this as the base technology, as the core technology for the first Streamlio product. Now, what is difficult though, like and you can put on the lessons learned category here, is that like building open source community is very hard, and getting the approval stamp of, okay, this technology was proven in Yahoo, this sort of technology was proven in Twitter, is good, but it doesn't get you much farther than that. As in that you still have to convince companies to adopt that technology, and in many cases, it's since we are talking about putting this technology in some of the critical paths, in some of the critical products, it takes a lot of convincing. As in, I was like making the parallel with the other technology for analytics databases, like products like Pinot or similar. I think it is much easier to convince people to switch these kind of technologies, because you can spin up a new cluster and do the same analytics with a different technology. And if it is working better, if it is cheaper to run, you have a very good argument for switching. But switching messaging and switching storage and switching compute basically requires rewriting your application in many ways. Therefore, it is much harder to get people to convince that to adopt technology, evaluating, adopting, and going to production with that technology. So I think that the lesson learned there is that you need to kind of like take the time to work with the community and to really understand what we can build that can empower open source developers and that can make them want to use this technology, which in many cases it is different from what the engineers in Yahoo and Twitter needed to build their product. So there is a lot of like different angles there. So and eventually we got there, right? But it takes a long time to build that, see that the community working with the community and really understanding developers and the potential for technology and make them understand. So the other part is that I believe that is other lesson learned is that until you have that kind of like community seated in and running on its own a bit, it is pointless to build a product and to try to commercialize a product because it's kind of like as a startup you have limited resources obviously and you have to focus on one thing. If you try to kind of like build a community and build a product at the same time, it's kind of like you're spreading really too thin and you try to sell a product that nobody knows that he wants. So it is much harder than instead let's build a successful open source community and have people come to us and ask for the product. Right?
In some ways, looking back on Streamlio, I think you were just a bit too early because now there's a whole bunch of startups now doing what you were doing of PubSub plus real-time processing. And in some ways, to your point before, you had to create that market, and now all these startups are taking advantage of the market that's already there.
Yeah, but and we need to understand really like what the right timing for the commercialization of the products, right? And but I do think that as a community we went like long ways from that point. And the other realization is that you cannot really hack the growth of the community. I mean, you can do stuff to help that organic growth in the community, but it is not that if you put more effort or if you put more money, that problem you can do it faster. I think there's like this inherent time that it takes for people to get themselves convinced that okay, this is the right choice, and in many cases it takes for people to be aware of there's a project, there's the technology that does X, Y, and Z, and understanding okay, maybe it could help me to build my next project, my next service, and it will take the time for them to understand the system, to try it out, to play with it, have a prototype using Pulsar, and then eventually go into pre-production, and then and so on. So that kind of cycle, like even if you try to push it, it will not get shorter, right? Because it still have to work on a timeline that is comfortable for users.
It is. So out of Streamlio, you sold to Splunk. And I think this is an interesting question, especially now, given that I think a lot of startups are going to have to sell to, or not have to, but will be selling to bigger companies. There's going to be a lot of consolidation in the market, I think. What advice do you have for those founders?
I don't know. I think each case is different. In one way, we had decent alignment of intents with Splunk, as in that. So Splunk had project product based on a streaming technologies, and but what they really lacked, it was around experience around messaging and compute essentially, and so we were able to step in and to like replace the prototype that we're doing with Kafka or Kinesis, and use Pulsar and productionize it with Pulsar at very large scale, with like hundreds of gigabytes per second of traffic. So that was something that you cannot typically do if you don't know the technologies very well, and that's true for any technology. So that they had a need on expertise on that on that area, and that's what we kind of brought in there.
And so I think that we're going to see that as that trend. In fact, one of the companies I worked with, they were acqui-hired. So we're going to see an acquisition for, we need engineers with a skill set. We're going to see, in your case, we need technologies and engineers with a skill set. So it'll be some interesting times for consolidation in the market. So at Splunk, oh, go ahead.
That for us, the important part was that we're going to bring not any expertise, but the thing we kind of continue working on what we have been working on essentially, and continue doing that as a team within the company, which is different from like a generic acqui-hire, which is more like less targeted.
And so with Splunk, what do you think went well, other than being able to work on the project and continue to improve it?
I don't know. I think we've been able to bring value very quickly there, by productionizing Pulsar within Splunk for both like these streaming products, as well as as a platform for internal Splunk product to use Pulsar, and we were able to do it fairly quickly for the times and timelines of a bigger company, which we're kind of like is always way much lower than what as a startup person you would like, but that's how it is. So being able to get that to production and to show again the value of the box, and to for many different applications, right? From like log ingestions to like other internal systems and so on, and also being the base of a front user-facing product. For what didn't go well, I can. So one of my biggest frustration was that so Splunk has a very different target that what we were used to have in Streamlio, right? And so if you think that for something like Pulsar, you have to kind of like convince developers that are building applications that this is the best platform that you can use to build your next application, right? If you're building like event-driven application or complex system with multiple services, you should be using Pulsar because that. But we're telling this to developers, while Splunk in reality is their customer target is very different. Is more like IT kind of departments, security departments. So they don't have that strong view on the developer mindshare. And in some cases, like we had customers of Splunk that were using the streaming product and were using Pulsar directly because it was the most efficient way for them to get data into the system, right? And after that, they were asking, can we also consume the data using Pulsar consumers? And I was telling them, yes, of course you have access, but like Splunk product people would say, no, you cannot do that. This is not a developer platform. This is like some other platform. So you should be doing this DSL language and this other UI. And I say that does not make any sense to these customers, right? And that they're asking us for low-level API access, and they're thinking of their problem as a lower-level problem, not as an IT problem with some DSL and some query that they want to run. And so I think that was my main difference there, and I do believe that there is a lot of potential in giving developers the right tool, and in some cases, yes, having high-level UIs and high-level constructs is perfectly fine to enable some of the use cases. At the same time, like you shouldn't be preventing this more like lower level, more efficient access there.
Okay. Well, let's talk more in depth about Pulsar. So if you wouldn't mind grabbing your
Sure.
So if you wouldn't mind grabbing your tablet, let's go ahead and start drawing
Yes.
this out.
Okay. I hope I'm not terribly bad with this.
Well, this is where your accent won't matter anymore. Your drawing matters.
So where do we start with here?
Well, let's talk about in a general sense, it's a pub sub. So let me see how is Pulsar part of a pub sub?
Sure. So if you look at pub sub, so the first thing is okay, we can have a really big black box here, right? And which is the Pulsar service. With my handwriting is very bad, but if you have this big black box, now you can see that this is kind of like a hub kind of model. Now you can have producers. So you have application one, and which is acts as a producer, and then it sends data, and then you have maybe application two that receives data, and it is a consumer of this data. Now this is a very simple thing, and the next step here is that you don't have a single channel of communication. You can have as many channels as you want. So each channel, essentially, it is called a topic. So you have T1, topic one, and topic two. And then you can have as many as you want. So all these different channels are independent from one another. And essentially, you can use them as kind of like the base point of interconnection between different systems, different components, different services, or different applications. Now, whenever you see, like on the producing side, it is very simple, right? So let me take a new page. Okay. So if you see of a single topic, right? Essentially, it is in Pulsar, it is viewed as a log, essentially, right? So in a log, basically you are adding new items at the end. So this could be messages could be stored in this order. So you have message one, message two, message three, message four, and so on. And you have the producer appending always at the end. And you can have as many producers as you want, right? So you can have producer one, producer two, and so on. Two. And on the other hand, now we have consumers. Consumers are also actually, let me take this back. See, this is always the challenge here is are we going left to right or right to left, and I mixed it up. So in this case, this will be the latest message, right? So this will be 4, 3, 2, 1. So sorry about that. And now you have consumers. So consumers essentially are getting that log, are reading through that log. And in this case, you will have consumer, and 0. So now you have a consumer that is reading at this position. And one important part in the Pulsar is that each consumer, it is attached to a subscription. And the subscription point it is stored by the system. So this is kind of very different from other technologies like Kafka. So in this case, so consumer it is reading that message 1, and everything before message 1 was acknowledged. So 0 and everything was already processed and acknowledged. That means that the important part here is that as a Pulsar broker will know that message 0 is already done processing, and it was dispatched and acknowledged. Therefore, we can get rid of it, and we don't need to retain it for, say, 3 days because it has already been processed.
This is also called a high watermark. So it's everything plus
yes,
everything here backwards is completely gone, and that's one of the limitations of Kafka.
Exactly. In Kafka, basically, the only way you can do this is through retention time. So you have to set, I want to keep the data for 24 hours, 3 days, or X amount of time. Now, it's kind of like a pessimistic scenario, in which case you assume that you have to retain your data always for the maximum amount of time. In Pulsar case, you can also have that if you want, but you don't need to because of this retention based on the subscription. That means that since we delete the data as soon as it is consumed and processed, we don't need to basically have upfront commit the disk space for, say, 3 days of retention for any topic. We only need to store data for 3 days for topics that are not consuming, right? And that's very important, especially in a multi-tenant environment where your downstream application will not be having an outage all at the same time. So if one of your users have an outage and cannot consume data for some time, you can grow up and use all the available disk space, but you don't have to commit it upfront for all of your downstream consumers. So yeah, this is one of the first difference. The second one is that we think that this as this is a cursor and this cursor is moving forward. It's tracking the producers, right? So it goes from the old message to the newer messages. We do also have multiple ways of consuming data, and essentially a cursor is associated with a subscription, but a subscription can have different types in Pulsar. So we have 4 fundamental types of subscription, which is, if you look at one topic, we have so you always have your producers on the topic and the sense data, and now you can have different subscriptions on the same topic. So you might have subscription S1, which is exclusive. Now, exclusive means that there can only be one active so one consumer can be attached to one consumer. Or you might have an S2 on the same topic, which is failover. Failover essentially means it's similar to exclusive, but there is one active consumer. So you can have as many as you want, you can attach, but one active, only one would be active, and the rest would be in standby. So this is failover. Third one is kind of like a very different model, which is shared. In the shared case, we can attach multiple consumers on the same subscription. So now we have multiple consumers. And the data is kind of like, it is delivered in round robin. So we have round robin delivery. Essentially, the shared subscription lets you implement like a queue consumption model, as you can add and remove consumers as you like, and it's kind of like detaching the topic concept from the processing capacity, right? So even if you have a single topic with a single partition, and I will get what partition means in this context in a second, right? But you can have one consumers or thousands consumers or 10,000 consumers on a single subscription, and it is fine. And so it depends on how much processing capacity you need, and if that load goes higher, then you can add more capacity on the consumption side without changing the structure of the topic or without doing any complex operation there. So it is like very dynamic, and the only restriction here is that the data is delivered out of order, because we're doing round robin, so there is no more correlation between the data, the order of data in the topic and the order in which it is dispatched, because we might send, say, message 1 to consumer 1, and then message 2 to consumer 2, and then basically consumer 1 fails, and we have to replay that message again to consumer 2, right? So and we'll see an out of order. But if you don't care about ordering, then shared model is the way to go. And the fourth one is kind of like the hybrid model, which is called key shared. So key shared is kind of like a hybrid between failover and shared. So in key shared model, we can have multiple consumers. But we do have per key order. So the way it works is that there are different ways of configuring that, and can be a bit static assignment or dynamic assign for different purposes. But the key property is that you can add as many consumers as you want on each topic or on each partition, and the dispatch will be done in order for the key of the message. And at the same time, you can add more consumers or remove more consumers. So if some consumer crash, the keys that were assigned to this consumer will get replayed to other consumers in order. So it is a very simple way of achieving that consumption side scalability of the processing logic without having to think about partitions and having to do a complex thing around partition. So I mentioned that how does this work within the concept of partition? So essentially, it's kind of like the same. So if we expand this topic now, we also support partition. So when you publish on a partition topic, essentially you have single topic is composed of multiple partitions. In Pulsar, partitions are essentially a composition. A partition topic is a composition of multiple partition. So multiple non-partition topic. What happens on the different subscription type, for exclusive, if you are on an exclusive subscription, you will kind of require exclusive access on all the partitions. If you are in failover, essentially like there will be one active consumer on each partition. I think they can be different. So essentially, it becomes very similar to the Kafka consumer group model, the failover one. And on the shared subscription, it becomes okay. It is shared on every subscription. So again, it is very flexible and very dynamic. But the key part here is that the number of partitions is not important anymore, and as a concept tied to the consumption speed. So if you need more processing capacity in Kafka, you will have to have more partitions because you can only have one consumer active per partition. In this model, you can still have partitions. So if you have, say, 1 million messages per second, probably you will want to use partitioning, right? But the number of partitions is only determined by I don't want to have a single partition to have a huge load that can exceed the capacity of one machine, but it is completely unrelated to how many consumers do I need to have to process this data. Because if you switch to shared or key share model, you can always have that ability to increase your processing capacity.
So let me help people in case they're kind of feeling overwhelmed with the different ones, and I'll go through a quick review of them. So exclusive is important because I've actually seen people try to do this with Kubernetes or something manually, and it's because Kafka doesn't have this. So exclusive is we have one consumer only running. If somebody tries to start another consumer on that subscription, it will actually exit. And failover allows you to have multiple running, but the other ones will stay alive, but they'll wait. So if you had, let's say, 3 containers, you'll have 1 active, and then 2 will just be kind of waiting in the wings. This shared one, this is round robin, and then you have this key shared. So key shared is giving a per key ordering, but it's each one of the consumers will get that ordering on a per key basis, so they can maintain that ordering. And this is actually important because in Kafka, when we have all these partitions, you can't break out of partitions in Kafka. It's architecturally designed not to, that you don't move out of this. So one thing that I think was worth pointing out, and you may have alluded to this, is that on the same topic, you could have consumers that are doing key shared and round robin, something that isn't possible on Kafka. It's not possible to do round robin and and key shared because round robin is done here at the producer level. It's not done here at the consumption level. And the reality is this should have been done at the consumption level rather than at the production level. So this high coupling between the producer and the way that data is loaded into these producers is actually a pretty solid limitation, and that limitation is removed in Pulsar.
Yes, it is two different levels of round robin, right? So one is to spraying messages across partitions, and your other one is how can I break out even one partition itself, right? Because if you need 1,000 consumers because your processing logic is very expensive, you cannot have 1,000 partitions. So having many partitions in Kafka is a very big problem because it's a management problem, is a performance problem. It requires a lot more resources to run and make many things much more inefficient there.
It does. So there's some pretty significant efficiency gains, and I would say architectural gains as well, where I went through and I read some of the KIPs, the Kafka improvement plans, where they're trying to mimic some of these features. There's one feature that you didn't talk about, and that's queuing. Pulsar's ability to do both messaging and queuing systems. So Kafka is trying to approximate this by making some changes here at the broker, some changes here at the consumer level, but they allude to it in the KIP, but I don't know for certain, is there could be some performance limitations as a direct result because they're trying to add something in that is not, Kafka wasn't designed for this, where I think it's really important to point out when you did Pulsar, you designed for all these sort of use cases initially. It wasn't added on later. Is that correct?
That's correct. Yes. So the like if you look at these four different creation type and kind of like trace it back to some of the concepts that we had in JMS, right? And that's not like a casual thing. Is that we had to basically convert all the use cases that people were doing with JMS or with RabbitMQ and all the technology and get them a ways to have the same semantic and the same functionality. Now, we didn't copy everything from JMS because of the limitation that were brought in by the JMS API, but we kind of like had to have similar functionality in order to have all these applications to be converted and migrated into Pulsar. And so I briefly read the keep for Kafka for around queuing consumer. I think that yes, it does look like something that is being crammed off on the current Kafka API, and I'm curious what would be the end looking state for this proposal. But yes, it does look like something that you're coming off of something that is a bit different underneath, and also has a lot of impedance mismatch between concept in the APIs that are right there right now. Like, and so essentially that ends up having things that, oh, you cannot call this method if you're doing this. If you're doing to consumer, you cannot call this offset checkpoint because that doesn't make any sense anymore, right? So you have a lot of coexisting methods in the API, but that you cannot call because they don't make sense together, depending on which mode you are in. And I think that it's going to be quite confusing from a perspective to understand all the relationship between the different concepts that are basically all squeezed in the same single interface. But yeah, I'm really curious to see how it goes. Performance side, I haven't looked enough into it to comment on that.
Yeah, and I don't think it's in a state that where they've written enough code to say here's the performance of it either.
Yes, I mean the only thing that I can say is that it takes a while. It takes a while to understand the impact of user doing certain things in different ways from an API perspective. Like we had like in the past, like I mean, before we could get to a solid state for these shared and key shared models, we went through the different stage of maturity, obviously, right? In the beginning, there was like issues here and there, and I think that some of the hard part there is to understand. We have basically a log storage model for Pulsar and for Kafka as well, right? And but we are kind of like tracking the consumption independently, right? So to do a shared subscription with out of order acknowledge, essentially we are kind of like we let the user to acknowledge a single message, and that can be out of order compared to other messages. That means that on your log structure now you have to mark some messages as
Here, Matteo, how about we diagram this out, or how about we whiteboard this out
okay.
on 4 because
Yeah.
I think it will be easier to visualize.
Yes, a good point. 1 second. So
if you go to screen 4, make sure you're on screen 4.
Yeah. Going back to this model of that we have the topic, right? So we have a topic and we have message. Again, this is the last one. So let's say for 10, 9, 8, 7, and so on. And here it is where the producer it is appending messages. So now we have kind of like a model where consumer can consume data out of order, right? And we say we have multiple consumers, and we have a watermark. In Pulsar case, we call it mark delete position because essentially you can say, okay, message 2 was mark delete, empty, and essentially everything up to here can be deleted, right? Now, from the other messages, some of them might have been deleted, some of them might not be. So in this case, we could say, okay, we have consumer 1 that has acknowledged message 6. So this has to be deleted. Message 8 has to be deleted, and maybe message 4. So what happens here is that we cannot delete any of the data starting from 3, right? So 3 is valid, therefore we have to keep it. At the same time, we don't compact this log, right? We are not the database, we are not RoxyB. So for a variety of good reasons. So we have to keep the data until all the holes are getting filled up, essentially. So until now, this can lead to a lot of funny situations, right? What if you leave one message and you acknowledge the rest 1 million messages after it, right? What happens there? Should we go on indefinitely or not? Or what if you have the kind of the worst case scenario? So in some cases, like for example, like if I acknowledge these 3 messages in Pulsar, what happens here is that what will happen is that we don't need to track 6, 7, and 8 acknowledgement independently. What we do is that we do a range. Essentially, we do a range representation. So if there are many messages in this range, basically we collapse. We just say, okay, everything from 6 to 8 was deleted. It can be 3 messages or 3 million, right? The worst case scenario is when you have 1 yes and 1 no, because in this case, basically we cannot compress the ranges. So basically we have to record that, okay, 4 was deleted, 6 was deleted, 8 was deleted. So now it is 3 different pieces of information. So there are a lot of ways in which like a user pattern can put strain on the system. Let's say one is one message left behind. The other one is that intermittent acknowledgement, and there can be there are several of these kind of cases, right, in which you basically are causing abnormal and optimal behavior and performance from the broker and from the storage, depending on the access pattern. So we have been working on these things for many years, and my expectation with them with Kafka would be that it would take for them to quite a bit of time in order to stabilize that feature and making sure that it is reliable and well performing under all the conditions, and that they have the right guardrails for the right in all the conditions. Another one, so the key shared, I do believe, I'm not sure that is part of their kit as well, but key shared is even much more crazy complex because in addition to this tracking of acknowledgements out of order and have this problem of where to store this information and what is the best way to store it, key shared also have to maintain the ordering. I don't know how to visually represent that, but essentially, like I can try to do like a quick thing, but we do have essentially one topic with a log, right? And now you have different messages with different keys. So you have basically key 1, key 1, value 1. Now you have key 2, value 1. Now you may have key 1, value 2. Key 3, value 1. So now we have to make sure that these, if you have multiple consumers, let's assume that we have two consumers here. So we have C1 and C2. For key share, we say that the same key should go to the same consumer. So let's assume that key one will go to C1, right? So we have C1 here. And so it will receive first key one value 1. And then this key 2 might go here. Key 2 value 1. Now, the tricky part is when there are failures. And the reason is that we may send this message here to consumer 1, and C1 might fail. So now what we can do? So if C1 fails, essentially, this message was tracked that it was sent to C1, and then now C1 is gone. Now I have to basically replay this message to C2. So after C1 fails, this will go to this different consumer. So now it will receive Q1 value 1, and then Q1 value 2. So now here there is an out of order logically on the topic, because Q2 was after Q1 value 1, but it doesn't matter because there are different keys. But just to illustrate that there is a lot of very subtle consideration in how to guarantee the order in the presence of failures. And this is like one simple failure, one consumer going away, but the replay can be very, very tricky, especially when you have, say, now a new consumer joining, like in this case. And the tricky part of a new consumer joining is that some of the keys that might get assigned to this consumer 3 right now, so some portion of keys now should go to C3. But if these keys were already sent to other consumers, we have to wait until these consumers can either process or fail these messages before we can have consumer 3 to start taking any traffic. So essentially, we have a whole state machine where consumer 3 will join, but it will be basically in an inactive state until a position in the topic gets acknowledged. At the point, consumer 3 will start with being actively participating in the dispatching. All of this to ensure the ordering under any possible sequence of failures. Again, these are very, very basic example. I can tell you that in practice, it took a lot of testing and a lot of like putting users, putting this feature in the hands of users to understand really like all the failure mode and understanding all these corner cases. You cannot just come up with a list of failures. It's really like you need to have like users doing that and kind of come back to you and say, oh, I had this consumption is stuck. Why is that? Or and so on. So it is very complex, and I would expect anyone implementing this sort of delivery mode to go through all these lessons in the same way.
Exactly. So here if people weren't following for some reason, we're diagramming out key shared, and Matteo makes the important point. Failures are the difference between, I guess, the ease of use and what could be for distributed systems. Because if you're using a framework, you're expecting that framework to handle all of this so that you don't have to handle these failures yourself. This is really key. This is why you use a framework. In fact, I saw a question the other day on Reddit where somebody was asking, why is everybody in data use all these frameworks? Why don't they do something else? Well, it's for this exact reason. I would never want a user to write this code. This is absolutely terrible code. This is difficult. This is error prone. This is going to take forever to do it. You want this centralized in your framework.
Yes, and yeah, it's not fun code to write. I can tell you. I mean, you start okay. This sounds like a fun project to do, but to get that to the right level of quality, it is really not fun. But and I think the most important part of the framework also and this kind of API is to offer strong guarantees. In many cases, I've seen systems that have, they say, oh, yes, we guarantee you that, but if you read the fine print, it is not 100% guarantee. It's kind of like best effort in multiple ways. And that's kind of the worst position to be in, because if you cannot trust 100% some property, then it's as good as not having that property, right? Like if you say, if we're telling you that you can use this feature and you have guaranteed delivery, it must be always guaranteed in terms of any kind of combination of failures, right? I don't care if there are like five nodes coming up and down in multiple different combinations that don't make any sense. The order has to be guaranteed. Otherwise, the whole feature does not make any sense if you cannot like always rely on it. Now that doesn't mean that there can be unavailability. Like in this case, some people were frustrated by the fact that I've added consumer 3, but it's not receiving any data. But and they say yes. I mean, it will receive it once the other consumers are caught up, and it can be like not intuitive to understand it, but it's as a system that's the only way that we have to ensure that we will not have any out of order event.
And the other thing that this reminds me of, you talked about Kafka not having this. So I did see that there is a GitHub project where people were trying to put this to create a key shared system, but they were doing it entirely key consumer side. So what happened was
Yeah,
there was a bunch of each one of the consumers would consume every partition, and that it has to be done server side, and they're just trying to, like many times with Kafka, working around limitations in Kafka with crazy workarounds and backflips, and I'm sorry, it just doesn't work very well.
yeah, it doesn't work very well because so I mean philosophically, I think that goes back to one question there, which is uh, when should a feature be implemented on the server side or as out of the box from a system we are building versus something that could be done outside, right? And if you look at this kind of like a behavior here of key shared, it is all based on you have multiple consumers collaborating and they need coordination to see which message goes to which one, right? Now, having that feature done outside, I mean, you can find hacky way of doing that, but it cannot beat the simplicity and the better architecture of doing that directly on the broker, because the broker knows who's connected, the broker knows who's consuming what, the broker knows what is acknowledged, what is not acknowledged, and so on, right? So, and in some cases that it doesn't matter where you are implementing this functionality, but in this case, it really makes night and day difference, right? You cannot build a good implementation of this kind of like dispatching just on the consumer side, because you will have to implement all this coordination logic in a third way now, right? So you have to have some ways of telling each consumer which message they should consume, which one they should not consume. You are reading the data multiple times anyway, so that there's a whole lot of different issues there.
Sure.
That's why I think that you cannot just implement everything on the client side. And I think there was one approach that Kafka always have done to have the broker as simple as possible, which in some cases I think it's a good model to have, but I do believe that some of the features they have a lot more value when implemented on the server side, and this is one of them. And things like these are things like delayed delivery that we do have also in Pulsar, Kafka does not have, but they all take advantage of having some complex logic implemented on the broker side that can be useful for many connected consumers.
Well, let's come back to that in a second. We've kind of talked about and go to board 6. What what is when is a time you would use Kafka over Pulsar? I sometimes I get that question.
Uh, if you ask me, that's a that's a uh, uh, so my answer typically is that there is overlap in terms of use cases. Obviously, right? That's things you could do with both Kafka and Pulsar. There is also many things that you cannot do with Kafka, and that you but you can do with Pulsar. Um, I, I would say that Pulsar in many ways it is a superset of the Kafka functionality. Like you can do everything that you can do with Kafka with Pulsar. Now, in some cases, there might not be a lot of difference from like from someone doing doing some like solving some use case with Pulsar Kafka. Like, and for example, like if you're doing like streaming analytics and you have one single use case and that's terribly not high volume and you're just like ingesting data and doing streaming analytics with Flink or other stuff, that might not make any much difference for you to have that either in Kafka or Pulsar. But if you are more on the operational kind of like use cases, like things like microservices, and or like you need more complex routing, more complex logic there, or that if you need more like most stronger durability guarantees around how the data is synced on disk in Pulsar versus Kafka, that might make a lot more difference for you. At the same time, if you need thing like queuing and we discuss like delay delivery, queuing, key shared, and so on, all these things that make a lot of difference in how you write your application. And finally, like if we've seen that people really understand the difference when running multi-tenant systems. So in many cases, we've seen people like deploying many tens of Kafka clusters. That's the model, right? You have one Kafka cluster per each of your use case. With Pulsar, since it's a multi-tenant system, people will generally deploy a single cluster and then have many use cases shared on the same cluster. Now you can have much better operations. You can have much better economies of scales and hardware utilization around that. But yeah, so if you're like on the analytics side, so you don't care about latency a lot, you don't care about like having a very strong durability, and you're a single tenant, single use case, then yes, you can do it with Kafka, and there's not going to be many differences there. Otherwise, yes, there is a very big difference.
So I drew out some of the ways that I actually draw this out for people to help them understand. Here's Kafka, and then there's Pulsar. Pulsar could do everything Kafka can do and more. So we alluded to one. Even you said one just offhand of what's called delayed routing or delayed messaging.
Mm-hmm.
I mean,
yes,
Kafka can't do that remotely. So it's a if you have that sort of use case, that's when you start reaching for Pulsar. And then I listed out the things. So if you don't care about durability guarantees, you don't care about latency. That if you have a simple low volume, if you have a single tenant, it's kind of funny. People watching maybe from big companies, maybe they're from small companies, and they don't understand this. At big companies, I know of several different banks where there aren't just 2 or 3 different Kafka clusters. There's somewhere around 10 different Kafka clusters. And it's simply because Kafka prefers a single tenant sort of situation, doesn't really break it up. It's weird. So that you can never achieve that economy of scale that you really want to have with Kafka, where Pulsar has this built in, that multi-tenancy.
Yes, and I've seen hundreds of clusters, so not just like tens. The of Kafka clusters there, but and economies of scale is one thing, and also like operational ease of operation is another one, right? Like if you have 100 clusters to manage, it is very different from managing one or a handful of clusters, right? How can you make sure that everything is upgraded and patched up and so on, right? The other one is that um, in a bigger organization, typically one of the biggest hurdle is to how can they make the data as easily shareable across different organizations, different teams, and there are two problems, right? One is okay if there are like access to this cluster with permissions and network and so on. And the other problem is not technical; it is more organizational. So let's assume that you have, like, say, team A that has their own service and that is sending data and consuming data. Now, team B might say, "Oh, you have interesting data there. I would like to have this data to also update my system." And so one very simple and stupid example is the account creation, right? So you have the account microservice that creates new accounts for your application. Now, when a new account gets created, sure, the account team has to publish a message, has to do something. Now, you can also think that you might have 10 different other teams that are going to be interested in that event, right? You might have, I don't know, the ad system team that needs to know that there's new account, or there is the marketing team, or there is like all sorts of different teams that will have to do something with this event. Now, if team A has their own Kafka cluster, which is isolated, and then they run, they might say, why should I let my cluster to be used by other teams? Now I'm managing this. If I now have like a keep adding more users, now I have to forecast the capacity. Now I have to have more. I have to do like a SRE work to onboard them into my cluster. They might cause unwanted extra load. They might cause outages on my cluster, and that I don't want to have. So it becomes like, okay, who owns this cluster? Who owns the operation, right? And if you have one team who owns that data, it becomes much harder for other teams to get access to that data. But if you switch the model, and in which you have a single shared cluster for the company, now I'm producing data and I'm consuming data, but I'm not owning that data. I don't care who else consume the data. That's not my problem anymore, as long as my SLA on producing latency and throughput is met. I don't care whoever. It's someone else's problem to ensure that there is capacity in this shared cluster, right? So it becomes much more easier from a organization perspective to have that shift of model, and if you need capacity on the shared cluster, you add capacity, but the capacity is shared across the entire company.
Well, let's go down that more. Go to Jamboard 7, and let's talk about what does Pulsar require operationally now. You've touched on, for example,
Yeah,
Bookkeeper.
yes. So Pulsar, yeah, it's composed of multiple. We are 6 or 7.
7.
So Pulsar, yeah, has. So first of all, yeah, it's a big architectural difference between Pulsar and Kafka and all the system is that we have 2 layers in the system, right? So Pulsar is composed of a set of brokers. We have broker 1, broker 2, 3, and as many as you want. And this, in general, like, this is behind a single DNS name or a single load balancer for service recovery perspective. So you might have a server discovery, and then, but in the end, clients will have essentially direct access to these brokers, similar to Kafka in this respect, right? And but at the same time, we also have I mean, it's on the same thing, but it is same cluster, but we have bookkeeper. So bookkeeper basically are storage nodes. So we have BK1, BK2, and so on. Now, in reality, the number of resources that you need compared to Kafka is the same. So you don't need more resources for this. More compute resources or not. The advantage though that we do have by having these two different layers in the system is huge. And mainly the first thing is that by having these two levels, we have this indirect access to the storage, and we can decouple where the data is located and where the data is stored. That means that we don't need to keep a single topic or a single partition entirely on one broker node like in Kafka. So the capacity of one, so the size of one partition in Kafka is determined by the size of the disk in one broker. Or that the availability also is determined by that factor that if the leader block goes down, then you have to get if you want to expand capacity, you have to copy particular data from one broker to another. It can be many terabytes of data that you have to copy. In our case, it does not work like this. Instead, the brokers basically they have no durable state. That means that topic can be assigned to brokers, but this assignment is very dynamic, and the topic can be very quickly reassigned to other brokers without copying any data. The data is stored in Bookkeeper, and but the data is also segmented. I can go on a new one. So if you're looking at one single partition.
Oh, sorry. Before you go to another one, I just wanted to point out that here on the brokers, we can scale our brokers independently from our bookkeepers. So if you have something that needs a lot of storage, you can, or less storage, for example, you could have much fewer bookkeepers than brokers, where Kafka, as you pointed out, those two things are synchronous. So if you need more networking, then you have to get more storage as well. And with this two-tiered system, you do have a benefit of scaling them independently.
That's perfectly correct. At the same time, it makes it much easier to say, I'm out of capacity of broker of serving capacity. I just need to add more brokers, and we can quickly add brokers and reassign topics to these new brokers without copying any data. And at the same time, if we need more storage capacity, we can do it dynamically. Just add more nodes, and in a few minutes, they will ramp up to the average traffic of the cluster. And in Kafka, you get to this partition rebalancing, which is going to be very expensive in terms of resources to achieve, right? So it's a very different model, but it has a lot of advantages there. And yeah, before I go to the next one, like that, we also have metadata layer. So metadata layer basically is storing which topics are there, where the data for the topic is located, and so on. And today, this metadata is essentially Zookeeper based, but it is a pluggable system. So we have been in the past year, so we have been working on a new system which has a very different architecture from Zookeeper, and it is horizontally scalable, which is called Oxia. We have open sourced it earlier this year, and we are currently starting the production rollout for this in few clusters. So essentially, it is a similar way that what we are using Zookeeper today for, but without any of the limitation around the throughput and around the size of the data stored in Zookeeper. So, and I was talking about that the data is segmented, and I think this is important as well. So if you're looking at, say, this like topic X partition 0, for example, so it's view one partition. So we see that logically a partition is stored as a log of messages, right? But in reality, we also have concept of segments, and these segments essentially. So basically, a partition is a list of segments. Now, these segments are between them independent. Can be different sizes. Typically, there are a few gigabytes as big, but and these segments are in reality for us are bookkeeper ledgers. So we have ledger 0, ledger 1, and ledger n. So each of these ledger, if you look at it, is essentially like has a bunch of messages, right? And but for us, it is the combination. So what happens is when like these segments basically after X amount of time or X amount of size, a new segments are rolled over and a new segment gets created. So because of the segments are all unrelated, they can be assigned to different storage nodes. So the important part here is that even if you have, say, one single partition in your cluster, and you have 100 storage nodes, we can use all the 100 storage nodes for a single partition because the segments keep getting created in different storage nodes, and they can be reassigned, and they get assigned to the entire class. So there's no like hard limitation given by a single disk size to how big a partition can be. And at the same time, if we do add more storage nodes down the road, the new segment gets created in 10 minutes will get assigned to the expanded cluster, right? So the whole cluster scaling for both broker side and bookkeeper side, it is very natural. Like you just add more nodes and you have more capacity, and shrink it, and the data will be reassigned.
Excellent. Well, how about let's talk, do one last question about Pulsar, and what excites you about Pulsar's roadmap coming up?
There are several things. In general, one of the main ideas we're trying to follow on is that what can we implement that makes the developers' lives easier? That has been like a repeating question for the team, and try to figure out what could we build that could empower the developers to build application in an easier way. And I mean, there are multiple things, and in a way, we are always trying to make Pulsar more polished to have much easier adoption in the community. But at the same time, there are a few different areas that we are intervening that could unlock a lot of potential there. And one of them is around like in if you look at many use cases in Kafka and but also in Pulsar today, you have a lot of so you're tracking a lot of different resources, and a resource could be a user, could be a customer, could be a car, it could be anything in that in your business domain that you want to track, right? And you want to see like all the events for this kind of resource. But today, people are kind of multiplexing everything into a single topic, essentially. That's and they do this because of the limitation of the infrastructure. That you cannot have a million topic, or you cannot have 10 million topics. It's too much, or it's too expensive, and it's unachievable. Therefore, you have to basically redesign your application, thinking in a very different way, and have the multiplexing factor. And in the process, you're losing all the visibility on what happens on all your your users. For example, like if you're multiplexing all the events for all the users in a single partition topic, basically you're losing the ability of seeing having any isolation across users. If you have one user that's sending 10x data for all the users, it will basically induce delays for even if you have one single message. and you have no visibility and no control over that, right? You don't know like who is sending more data and so on. Or if you say, I want to replay all the messages for this user, you have no way of doing that. So you will have to build that capacity outside. Maybe you can run a Flink pipeline, or maybe you can get data into some analytic database and so on. But it's a lot more infrastructure. It's a lot more complex as well. Instead, if you can remove at least some of those limitations and say that, yeah, fine, you can have 10 million topics in a small cluster. That's perfectly reasonable. Now you can just kind of roll back and think of having a map one-to-one between how you think about the problem and how the messaging lets you implement that solution. Now you can have one topic for each of the customers, and now you don't have to do any demultiplexing. Now, if you want to see the history of one user, you can just repeat that topic and on and on. Or if you want to have isolation, you can apply different rate limiting to individual topics, right? And you can avoid a user to have to cause delays on other users. So there are many pieces that we are doing for achieving these. The first one has been around metadata, and replacing zookeeper with docs is a big part of it. The other part is there are many other improvements that we're doing in the broker. Like one simple one, I mean, simple in concept, but is how we expose metrics has been also a problem. That if you have many topics, the way that we're doing aggregation of metrics is not scalable anymore. So we're going to give a lot more flexibility there, or the way the service discovery works. So we're making lots of improvement there to kind of like unlock all the potential for these use cases.
Well, good. I'm excited. So what comes to mind is I think a lot of probably the most innovation is coming out of Pulsar, and I think that innovation comes from the architectural um, how you architected it so that it can be added to, can be changed, can be
Yes.
you can make changes without going in too deep into the guts, as we're seeing with Kafka. Well, Matteo, oh, go ahead.
That it will indeed be very difficult in Kafka at this point to have support for this kind of many topic scenario. That's very different storage model. That's very different architecture model. So it's something that you cannot just add as a afterthought. I believe.
I agree. Well, Matteo, we're at time, so it's been a pleasure. Thank you so much for coming on. I really appreciate it, and sharing so openly and talking us through why some of the decisions that you made over time and how Pulsar works. So thank you so much.
Thank you for having me. It was a lot of fun.